High Peak Courses are a British Government registered learning provider with the UK RLP.
Hello, I'm Warren Lee. Welcome to High Peak Courses.
Lecture 2. Now that you've completed Task 1 of making the basic galley in CATIA 5 or SolidWorks, a future task that you may undertake, just to increase your portfolio and understanding of using CATIA and representing your aircraft interior work, is a slightly more complicated galley. This galley on the following page occurs more frequently on the aeroplanes. This galley is a rear galley found on a Monarch aircraft. The lower part of the galley contains the trolleys. I suggest you visit these two websites to get more details of the galleys and stowage units. AIM Aviation has a website, and also BE Aerospace. When you visit the website of AIM Aviation and BE Aerospace, have a look around. It's not just stowage units or galleys that these two companies design and manufacture. They do a variety of monuments of aircraft composite interiors, such as dog boxes and flight crew rest units. Now, just going back to the 2D drawings that you've done of the galley and the 2D drawings that you will do for the stowage unit, make sure when you do these drawings, add some more details, give more information. Just look at this example here in this PowerPoint. This shows the cross-section of the fibre lamp construction. It shows some attachment points where the screws are and some basic details. This enhances the drawing, provides more information for the engineers to use. Let's get on with Task 2. This is to construct in CATIA 5 or SolidWorks a basic stowage unit. When I say basic, this type of stowage unit is used frequently on board the airliners. I know because I've done many of these. And this is a typical configuration, so it's very valid. Take a look at these two pictures from AIM Aviation website of stowage units. Go on their website, have a look as much as you possibly can. You'll see a lot of variations on stowage units. Some of these stowage units may contain additional items that can be attached to the side, such as a baby bassinet, or a magazine rack, or a video monitor. Now, this sketch here actually gives you some dimensions you can work to. Just look at the dimensions, not the details of the boxes 1, 2, 3, 4, etc. But we have a Y direction minus 630 millimeters, a plus Y 630 millimeters. From those dimensions there, you can see this one is 340 millimeters wide. These are the coordinates in the aircraft, as it says here, and the height is 1500 millimeters. This is generic. It's not an exact one. They do vary. So with this information, you can start to construct, parametrically anyway, your stowage unit. However, if you go just a few more slides on, you'll see dimensions are also given for clarity. Now, the aircraft coordinate system. As we proceed from the cockpit, from the nose of the aircraft back to the rear, that is a positive x-axis. The y-axis is on the starboard side, positive, and positive z is in the vertical up direction. And you can relate the coordinates of the stowage unit, which also gives you the dimensions of the actual unit, but the coordinates you can relate to a position in the aircraft coordinate system. You will know exactly where in the aircraft this stowage unit belongs and its orientation, and on what side of the centre line, or maybe it's on the centre line. But the information is given by looking at the coordinates. So let's remind ourselves of Task 2, what the stowage unit looks like. Not the CAD model, not the finite element model, but this is what it physically looks like in real life. You can see it's narrow, it's a narrow rectangular shaped box. And the doors to the stowage unit are on the very end here in this particular example. But when you go into model later on in an FE system, we'll have a similar construction but one main door instead of two half doors. But for now, the CATIA model or the SolidWorks model will also represent the same as what we're going to build in the FEA system. The storage unit structure consists of rectangular parts. Basically, we see here from the top the roof panel, we have side panels, a centre partition panel, floor panel, and you can see there's a back panel there, and there'll be a panel opposite the back panel, but the doors will be located in one of those thin vertical panels. You have the dimensions. Later on, each panel in the FE system will be made totally independent, not connected. But for your CATIA model, you can do it the same way as you've done your galley model. These are the individual panels you can see here. This particular slide shows you the dimensions. I believe you have all the dimensions to make this either parametrically or otherwise. But it's always best to try and construct something in CATIA in a parametric fashion. Now this slide here, the stowage unit, shows two views, one without the end panels or the top panel on, and then the one on the right hand side shows the stowage unit structure with the door. Now this model you are creating in CATIA or SolidWorks is a solid model. It's a 3D model, and it should have 3D dimensions. In other words, the panels that make up this stowage unit, when you look into the CATIA model, should have a thickness. The thickness of these panels is 19 millimeters and 12.5 millimeters, 3/4 of an inch and 1/2 an inch. This is typical panels that they use. On the stowage unit, you can use all 3/4 inch. That's 3/4 inch thickness. Model this stowage unit as a 3D item. The difference is when we're going to do the FE model, we do not model it as a solid model. We use the mid-ordinate geometry. This image shows the internal configuration of the stowage structure. That's the centre vertical partition. Here's another view of the centre vertical partition panel, and you may see purple dots in various places. You can ignore these for the CATIA model, the SolidWorks model, but these purple dots signify a method of fastening the panels together. Don't forget, in this CATIA model, those panels need to be independently made and just located so it looks like the stowage unit. It's going to be similar in the FE model to come, where every panel is made independently, is not connected to its adjacent partner. In this view, you can now see the side door in place in the end of the stowage unit between those two horizontal yellow lines. Here's a view of the completed stowage unit. Note on the floor those little yellow triangular shapes. Those are the feet. This is how we represent these in the FE model to come. Here's a better image of the feet. There's 4 feet. We actually model those in FE triangular. I've just shown them here for convenience and for the location. You could put something in the CAD model that represents 4 vertical bolted connections. And finally, we have the completed stowage unit. You can spin this round in your CAD system, in your 3D system, put different colours on the panels to show different panels where they're going, if they are a different size, for example. And then the next task would be to produce the 2D drawing of this 3D CAD model. SolidWorks and CATIA 5 have this facility where you can automatically make a 2D drawing. Detail that drawing with more information, your name, the date, what the unit is called, the stowage unit, Now you should print out a few, well, now you should print out a 2D drawing, properly detailed, of the stowage unit and put this into your portfolio collection. This will go alongside your galley CATIA model drawing, show some colour plots in some printouts, something you can show potential employers what you've been doing, what you understand. Okay, lecture 3 will be next, where we go on to construct a stowage unit. It's important that you understand that the panels in the FEA model will be totally individual, not connected. We will connect them with special connection elements called MPCs, multi-point constraint cards. So that's just to prepare you. Maybe you can look into that, MPCs. Look into that when you look at on the internet, YouTube, under FEMAP or Nastran for Windows, some people call it.